All right. Hello and welcome back. I dropped something as I was starting this video. Okay, today I want to talk about extrema on an interval. Well, what are extrema? If we're looking at a function, an extrema is basically minimum and maximum values on a function. Okay, that's it. Extrema, they're the extreme values at minimum and maxima, and this is the plural. Extremum is our singular, and we have two different types of extrema. We have relative extrema and absolute extrema. Relative extrema are any time that we change from negative to positive or from positive to negative. So any change from negative to positive or positive to negative. That's our relative extrema, right? When we're going from down to up, up to down, okay? And our absolute extrema is the highest, or are the highest and lowest points, right? The highest and lowest points. So an absolute extrema can, of course, be a relative extrema. So it can also be the end point. So here in this graph, this is our absolute extrema. This is our absolute min, our absolute minimum. And our absolute maximum is here, so our absolute maximum. But our relative extrema, I'll box those. This is a relative extrema, 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 this is a relative extrema. So you can see that we have a relative and an absolute extrema here at this point, which is unlabeled, but we only have an absolute minimum here at this point, right? So I want to just point that out to you because we're going to be using it you'll be asked to identify them in calculus quite a number of times, but we can also talk about where these occur. Well, these occur at critical numbers. What is a critical number? A critical number is an x value of the function where basically where x equals c when I didn't define this very well, but f prime of x is equal to 0. Okay, it's just basically when the slope is 0, and you can see that here, right? If we drew slopes here, we know that we're going to have slopes of 0, right? So that's what's happening at critical numbers. But also here would be a slope of 0, here would be a slope of 0. The only time that absolute extrema can occur has to be at a critical number or an endpoint, okay? So here it's at a critical number, here it's at an endpoint, okay? These are not, I guess, actually critical numbers because they're just endpoints, so I kind of misspoke there. But anyway, we can also talk about the extreme value theorem. Well, what is the extreme value theorem, or EVT? If a function is continuous on a closed interval, a to b, then f of x has at least one absolute minimum and one absolute maximum on the closed interval, okay? So does the extreme value theorem apply? You're going to be asked that. Here we have f of x is equal to 2x minus 3 over x minus 2 on the closed interval -4 to 4, okay? So does this apply? It does not apply. Why? Think about this. Why does it not apply? It does not apply because it's not continuous. Not continuous at x equals 2. So we can't apply the extreme value theorem. Well, let's look at our next one. Here we have g of x is equal to e to the x minus 2 plus 1. Is it going to apply here? From -5 to 5. Well, yes, it's continuous. So yes, it will apply. Does it apply? Yes, it's continuous for all the reals there in between that interval. So yeah, it's going to work. What about here? H of x is equal to x times the square root of x plus 2 from the interval from -6 to 6. Well, this is only continuous for x is greater than or equal to -2, right? Because if I had something less than -2, I'm going to have a big problem there. So, no, this does not apply either. All right, so hopefully that makes sense. Let's do some examples here. We want to find the absolute extrema of the function on the given interval, provided that the extreme value theorem is applicable. So if not, we're going to justify y. Here we have f of x is equal to 8x cubed minus 3x squared minus 9x plus 2. We know that these absolute extrema have to occur at critical points or at endpoints. So first thing I'm going to do is first I'm going to find my derivative. So I have f prime of x is equal to 24x squared minus 6x minus 9. And I'm going to actually take out a 3, I guess. So that's equal to 8x squared minus 2x minus 3. And I'm going to set this equal to 0. Okay? So if I factor this out, first I divide by 0, but I'm going to get 4x minus 3 times 2x plus 1 is equal to 0. So I know x is going to be equal to 3/4, or x is going to be equal to negative 1/2. Cool. Well, now I need to actually test these points. So I'm going to make a chart. So I've got my x and my f of x. Okay. So my x's that I'm going to test are going to be negative 1, because I need to test my endpoints too, 2, 3/4, and negative 1/2. And all I'm going to do is put these in for f of x. So f of negative 1 is going to be equal to 8 minus, that should be a negative 8, minus 3 plus 9 plus 2. So 8, 9, 10, negative 11 plus 11 looks like it's going to be 0, right? So negative 1, 0. And then if I do f of 2, I'm going to get 64 minus 12 minus 18 plus 2, which I think is going to be 36. Okay, and I'm going to use my calculator for this one. I'll pause for a second while I type this. Okay, I got f of 3/4. I just used my calculator. We got negative 3.0625. I guess I could write that as a fraction. It's like negative 49/16, but that doesn't really help me too much. And then negative 1/2. I'll pause again. Okay, I didn't film this, but I did negative 1/2. That was negative 2.25. So we need to say what's our absolute maximum and our absolute minimum. Well, our absolute maximum and our absolute minimum, that's what we're trying to find here. Looks like our absolute maximum, our highest point, is going to be 236, right? So it's going to be 236. And our absolute minimum, our lowest point, is going to be 3/4 comma negative 3.0625. Or you can write it as a fraction, doesn't really matter. Okay, hopefully that made sense. Let's do one with our calculator here. Okay, I'm going to go to my calculator and type in sine squared. Oops, first I'm going to do this. Sine of x, quantity squared, minus cosine of x. Always fun to graph. Graph that out. And actually, now that I'm thinking about it, I used my calculator earlier today, and I think I put it in degrees, and I didn't put it back into radians. That might, yep, there's our problem. Okay, graph that again. Ooh, that looks a little bit better. Well, now we need to find our derivative. I'm going to do that by hand. I know how to find my derivative. So my derivative is h prime of x is going to be equal to 2 sine x cosine x minus, or actually plus, sine of x, right? And we need to set this equal to 0. Okay, so if, one second here. Okay, so I'm actually going to solve here. So I'm going to factor out sine of x. So I'm left with 2 cosine of x plus 1 equals 0. So I have sine of x is equal to 0, and cosine of x is equal to a negative 1/2. So it looks like x could be equal, or is equal to 0. Sine of x is 0 at 0 and at pi. And cosine of x is negative 1/2 at 2 pi over 3. And again at 4 pi over 3. Okay, so now I need to actually test my points here. So I'm going to make that chart, x and f of x. And I'm going to test 0, pi, 2 pi over 3, 4 pi over 3, and I already have 0 there, but I also need to test 3 pi over 2. Okay, right? So this is when I'm going to go to my calculator, and I'm going to just trace these things. So I'm going to trace 0. At 0, we're at negative 1. At pi, we are at 1. At 2 pi over 3, we're at 1.25. At 4 pi over 3, yes, right? We're at 1.25. And at 3 pi over 2, we are at 1. So do we have an absolute minimum and absolute maximum? Well, it looks like we're going to have some, right? So our absolute minimum is going to be at 0, negative 1. And our absolute maximum is going to be at 2 pi over 3, comma 1.25, and again at 4 pi over 3, comma 1.25. Pretty cool. Okay, let's do one more, our final example. F of x is equal to the natural log of x squared minus 9 on negative 2 to 5. Can we use extreme value theorem to find our minimum and maximum here? Well, take a moment and think about this. Pause for a second. Okay, hopefully you've come back and thought about it. We have our natural log here. Well, actually here, this is undefined. Undefined from negative 3 to 3, right? And actually, if I graphed this, I could do that. Like, I can graph the natural log of x squared, x squared minus 9. Oh, look it. I've got this big gap here. I've got this big gap from negative 3 to 3. It's not continuous from negative 2 to 5, right? So we cannot can't apply the extreme value theorem, right? Therefore, we can't find our absolute minimum or absolute maximum. All right, hopefully all of that made sense. If you have questions, leave them in the comments, and I look forward to seeing you in class. Bye.